Question number 10. The sum of 2-point charges is 7 microcoulomb. They repel each other with a force of 1 Newton when they kept 30 centimeter apart in free space. Calculate the value of each charge. So first, let us assume that two charges are Q1 and Q2. So the sum of these 2-point charges is Q1 plus Q2 is equal to 7 microcoulomb. Or we can write it as 7 into 10 to the power minus 6 coulomb. Now they repel each other with a force of 1 Newton. So force is equal to 1 Newton when they kept 30 centimeter apart. That means R is equal to 30 centimeter, which is 0.3 meter. Okay. So first we're going to use the formula of Coulomb's law, that is F is equal to K Q square. Here it would be Q1 Q2 divided by R square. So F is 1 Newton, K is 9 into 10 to the power 9, Q1 Q2 is not known, so Q1 Q2 by R square, which is 0.3 square. So from here we will be getting Q1 Q2 is equal to 0.3 square divided by 9 into 10 to the power 9, which is equal to 10 to the power minus 11. Okay, so now here we can assume this as equation number 1, and here we are getting Q1 Q2 is equal to 10 to the power minus 11. Okay, so we know from an algebraic equation that Q1 minus Q2 whole square is equal to Q1 plus Q2 whole square minus of 4 Q1 Q2. Okay, so from this we can use this. So 7 into 10 to the power minus 6 whole square minus of 4 into 10 to the power minus 11. So this is 49 into 10 to the power minus 12 minus of, we can write it as 40 into 10 to the power minus 12. So this would be 9 into 10 to the power minus 12. So from here we can write this Q1 minus Q2 would be square root of 9 into 10 to the power minus 12, which is equal to 3 into 10 to the power minus 6. Okay, so now we have Q1 plus Q2, which is 7 microcoulomb, and now we have this Q1 minus Q2, which is 3 microcoulomb. We can write this as equation number 2. Now we can use this 2 equation to calculate each of the charges. So Q1 plus Q2 is equal to 7 and Q1 minus Q2 is equal to 3. So just use this. So Q1 and Q2 cancel out with each other. 2 Q1 would be 10. From here Q1 is equal to 5 microcoulomb, and if you put this value of Q1 in equation number 1, then it would be 5 plus Q2 is equal to 7. So Q2 is equal to 7 minus 5, which is 2 microcoulomb. So this is our answer. So the charges are, the question is calculate the value of each charge. So the first charge Q1 is 5 microcoulomb and Q2 is 2 microcoulomb. Okay. Question number 11. 2-point charges Q1 is equal to 5 into 10 to the power minus 6 coulomb and Q2 is equal to 3 into 10 to the power minus 6 coulomb are located at position 1 meter, 3 meter, 2 meter and 3 meter, 5 meter, 1 meter respectively. Find the forces force F12 and F21 using vector form of Coulomb's law. Okay, so here two charges are given. Q1 is equal to 5 into 10 to the power minus 6 coulomb and Q2 is equal to 3 into 10 to the power minus 6 coulomb. And the coordinate of the first would be I cap plus 3j cap plus 2k cap, and R2 is equal to 3I cap plus 5j cap plus k cap. Now suppose the two charges Q1 and Q2 are located like this. and the distance between these two charges is r. Now both of these charges are positive charges, that means we can see the repulsion force between them. So the force on charge q1 due to q2 would be F12, and since this is a repulsion force, the direction of this force would be in this direction. Okay, and if we consider a unit vector along this direction, that means along q2 to q1, so we can write this unit vector as r21 cap. Okay, that means from Coulomb's vector law, we can write this F12 is equal to K q1 q2 by r21 square into r21 cap. Okay, now if we talk about the force F21, which is the force on charge q2 due to q1, so the direction of this force would be this direction, so this is F21, and the unit vector direction would be along this direction, so this would be F12 cap. So F21 is equal to K q1 q2 by r12 square into r12 cap. Okay, so first we are going to calculate this one only. So for that we need r12. So r12 is basically r2 minus r1. Now r2 is 3i cap plus 5j cap plus k cap minus of I cap minus 3j cap minus 2k cap. So this would be 2i cap plus 2j cap minus k cap. So the mod of r12 is equal to square root of 2 square plus 2 square plus of minus of 1 square, which is equal to square root of 9, that means 3. So now we have got the value of r12 and r12 vector and the magnitude of r12, because we know unit vector r12 is equal to r12 vector divided by mod of r12. Okay, so r12 is 2i cap plus 2j cap minus k cap divided by 3. So from here we can calculate F21, which is equal to K into Q1 Q2 by R12 square into R12 cap. So K is 9 into 10 to the power 9, Q1 is 5 into 10 to the power minus 6, Q2 is 3 into 10 to the power minus 6, R12 cap is 2i cap plus 2j cap minus k cap divided by 3, and r12 square is basically 3 square, which is 9. So 9 will cancel out with each other, 3 will cancel out with each other, and we'll be getting 5 into 10 to the power minus 3 into 2i cap plus 2j cap minus k cap. So this is the value of F21, which is 5 into 10 to the power minus 3 into 2i cap plus 2j cap minus k cap. Now from the theory only, that if we have this kind of scenario, and from the diagram only it's very clear that this F12 and F21 is the direction of these two forces are opposite to each other, right? So from here only we can write that F12 is minus of F21. So we are going to use this relation and we can write, so the value of F12 is equal to minus of 5 into 10 to the power minus 3 to 2i cap plus 2j cap minus k cap. Okay. So this is our this is our answer. So the forces F21 is this, and the force F12 is this.